Hello everyone, welcome to this new lecture on the functions with vectors. In the previous video, I covered what are the basic concept of functions and how do we use function in MATLAB scripts. Now in this lecture, I will give some example related to this electrical engineering background and especially power triangle. So in power triangle, we have three components. One is real power, reactive power, and apparent power. In single code, how we can find out both all these components using a function with time series or a column vector of each input. So input will be a vector size, and you will get multiple outputs using some function in MATLAB. So this we are going to cover in this lecture. So this thing I have already covered, what is a function and what is the use of function, why we use function in general in any computational process. We use function because if we want to retrieve a value of output using different sets of inputs, then we do not have to calculate again and again uh, using some hardwired computation. We can use a simple soft coded computation, and we can change the input values and get the output values iteratively. So this image shows the number of input variables may be more than one. On the right hand side, you can see number of input variables are more than one, and number of output variables are also more than one. So here you can see number of input variables are more than one, number of output variables can also be more than one in a single function. So this is a function which will be designed in MATLAB. It will be coded in MATLAB, and this function word is a inbuilt command. It defines the code is a function, and on the left hand side, my fun is a custom name for the function which can be customized by the user. Clear? And coming to the power triangle, so this is a power triangle where we have real power, reactive power, and apparent power. So real power depends on three components. One is voltage, current, and power factor. So in the previous lecture and previous example, I had taken only two inputs, V and I. So assuming that it is working at unity power factor, but here we will take some phase difference between voltage and current with pi angle, and we will find out real power, reactive power, and apparent power, all three, in using a single command. Now coming to the MATLAB, I have already designed our function with two inputs. With two inputs, it is already designed, where you can see this function. You can check that this function file is already present in my folder, in my directory. It is already present, power underscore calci. So you can open this code. You don't have to change anything, because it also takes two inputs, and in my this main code I have also given two inputs, but only change is that I have taken two inputs, V and I, which is of time series format. So when you run this code, you will get three vectors in the workspace. So I have already saved this code. This is the main file. So when I will run this code, I will get three variables in my workspace. Sorry, four variables, because power will also be generated. So here you can see I am okay. So here the first variable is t. So t is a vector which is which has elements from 0 to 0.02 with a resolution of 0.001. This I have already discussed in the second lecture and third lecture, how the vector variables work and how we can generate them. Similarly, this is taking the input of t. In the second line, we are generating V, voltage, and generating current. So these are randomly generated vector values. So these are not from any electrical systems. These are taken randomly for example purposes. So we have three column vectors which are generated in the workspace. So there are T, V, and I. T, V, and I. And then this V and I are taken as input by the power calci function, which is given here, and these two inputs are calculated iteratively, element by element. So element by element, these are multiplied, and for each element position, a separate p parameter, p variable is obtained. Then this p is saved one by one in this workspace area. Element by element, this p is saved. Then after saving, when this all elements are calculated and all element position p is obtained, then we will get a final vector which will be of same size of the input vector. So input vector, you can see it is 21 size, 1 cross 21. Output vector is p, it has also 1 cross 21 size. So you can see size is always constant for the input and output. When it is over, then we are plotting t and p. Then we are plotting t and p. So this plot is available here. So this is a general plot, and how to plot, format, and export any image from MATLAB to your local PC or folder directory, I have already covered in the previous lecture videos. Okay, so this is related to any formatting. If you are satisfied with this plot, you can directly copy from here, or you can export this diagram, this plot, to PNG image using some fixed DPI. Okay. So what is this? This is the instantaneous power where unity power factor operation we are considering, because we are taking only V into I. So here you can see the power is increasing and then power is again decreasing for each half cycle. So this is a half cycle, 0 to 0.1, again 0.1 to 0.02. So for each half cycle we have some peak and then crest and dip. Okay, like this the power waveform is obtained. Clear? Up till this example is clear, I think. So now I will move to the next example in the same video. So before moving, I will clear everything by in the command window by pressing CLC. I will also clear my workspace. Okay, again I will clear my command window. Okay. Now in the second example, I will show you uh, how to extract multiple outputs from a single function. So this is a function code. This is a new function similar to power calci that we used in previous example. This is a new function where the function name is electrical underscore params. Okay. So this electrical underscore params function takes three inputs: VRMS, IRMS, and phi. So VRMS, IRMS, and phi. What you can understand from the nomenclature also that Vrms is the RMS value of voltage, Irms is the RMS value of current, and phi is the phase difference between voltage and current vector. Clear? So we want to find out all three components of the power triangle, which are real power, reactive power, and apparent power. Okay. Then these are the three outputs which are given here, and on the left hand side we will define the different inputs. First step is to save this function. Automatically you will see in the dialog box file name will be already mentioned. You don't have to change the file name, it is already mentioned. You just have to press save. Then you can see a new file is created in the file directory electrical underscore params. Clear? So this function is now saved. Now this is our main file. So this is our main file where we are giving three vectors, three elements to each vector. So Vrms is a vector because it has three elements. I am assuming that all three values of voltages are same, because in practice, in real life, the RMS value of supply voltage is almost same. It is not much varying, almost same. Okay. But IRMS current value can change from 5, 10 to 15, and phi is also assumed to be changed, and the phi is taken in radians. It is taken as 0, pi by 6. Pi by 6 means 30 degree, and pi by 4 means 45 degree. So we have taken three sets of inputs for each vector. Now when I run this, before running this I have to save this code. So you can give any name. I am writing it as my fifth code. Okay. So now this is saved. Then when you run this, so first of all these column vectors will be saved in the workspace. Then when you come to the fifth line, when the compiler tries to execute the fifth line, then it will take inputs one by one element wise and feed these inputs to this code, to this function electrical underscore params. Then this function will one by one calculate the values of P, Q and S, and one by one it will be saved in the workspace again. So we have discussed earlier that size is same for input and output. Okay. So here we can see we have three vectors for each input in the for each input. So for each output we will also get three vectors, three elements. Okay. So I am now trying to run this code. So in the command window you can see that P is having three elements, Q is also having three elements, and S is also having three elements. You can verify this using this workspace also. So due to values are very large, it is not showing completely, but the size you can verify. All three inputs and all three outputs have the same size. So we can see that if we have multiple inputs and if we want to find out multiple outputs, it is possible in MATLAB using simple codes, and how to write those codes and how to define functions and main files I have discussed in this lecture video. If you have any doubts or any queries or any suggestions, you are welcome to write those in the comment section, and thank you for watching.